Hello everyone. I welcome all of you on behalf of Edureka, guys. So let's start, guys. Let's start with our today's webinar. So our today's webinar is going to be on continuous improvement through DevOps tools. Okay. So let's see what we are going to talk over here. Let's see what is our agenda for today. So the agenda for today is going to be what is a continuous testing, what are various types of testing, and then we are going to talk about some of the types of tools that are used for continuous testing. Okay. And then we will be looking at up on a small demo part, like how we can automate testing. Okay. That is what we have to see in our today's session. Okay. So let's start, guys. Let's start with continuous testing in DevOps. How do we test it up? Let's see that over here. Let's discuss what exactly DevOps is, what are different tools that are being used over there. And then we'll see a small demo, like how, when I'm running a pipeline, the testing will happen. Okay, so let's start over here. First of all, what is testing and what is the difference between a continuous testing and an automation testing? That is what we have to discuss. Okay, I think the word test means simple, testing, test. Test means to test something, whether it is working fine or not. You have developed something and you want to see if it is working fine or not. That simple thing is called as testing. Okay. Now, testing can be of two types. It can be a automated testing, automated testing. You call it as automation, or it can be continuous testing. Now, what is the difference between continuous testing and what is the difference between the automation testing? Okay, like for example, I've deployed an application. Okay, I have an application running on the server. I go onto this application, I open the web page, and I'm putting the data and I'm seeing whether the response is correct or not. I'm doing all these things manually. All the things manually by my hand. Like developer has developed the application. After the development is done, I just open the application, enter required fields, enter required data. After that, I simply see that it is working or not. I get the desired output or not. That is what is a manual testing. But normally, nowadays in the IT industry, manual testing has a limited scope. Manual testing only comes into the picture when you cannot automate it. Okay, but normally now, all the things can be automated in the IT world. How? Using some automation tools. Okay, we have some smart tools that can automate writing the test cases. What is a test case? What is a test? What is a test case? A test case is basically a procedure that describes like what should be the input and what should be the desired output. It's a procedure how to test something. That is called as a test case. So earlier, if I talk about long back, what people used to do, these test cases were written manually. Okay. After that, the team sits out, they distributes test cases and they execute each and every test cases manually one by one. That was a time when we do manual testing. Okay. Then later on, with the enhancements in the technology, and to save the time, to deliver the product on time, people started thinking manual testing is tedious. First of all, a person can make a mistake. Okay, somebody can make a mistake during testing. And it's a person, let's suppose if he's on leave, then who is testing? The testing cycles, the time to test anything will be increased. So that's why people started switching to automation testing. Means here, you use some tools to code. Okay, you write the code basically using some tools like Selenium, JUnit. There are many tools available in the market. TestNG, there are many tools available in the market. Using those tools, what do? You write the code to test the application. You're writing a code to test it. Okay, so the complete procedure is coded. Then you simply execute that code. That code will go and test the application. On your behalf, that code will go and put the data and see whether the output is getting desired or not. If not, then it will show you the error that it has failed. Now, anyone in your team who knows how to run it can run it. Even if, let's suppose, I am the person who is running the test cases automation, I am on leave. If some other person is also know how to run it, he can run it on my behalf. So there's no blockage, and automation is really fast. You execute it, it will give you the output in like within few minutes, like whether all the test cases are passed or not. So this is what automation brings into speed and less chances of error. Because when a human being is doing it, there are chances that there may be errors coming in even after your testing. Okay, so that's why people switch to automation. Okay, now automation is done by using some tools, like you can use JUnit, or you may be using Selenium, any test cases you may be using, any test tool you may be using. So what is basically a continuous testing? We have seen manual, automation. Automation is done via tool. What is continuous? Continuous simply means it's automation test which is done continuously. What does the term continuously means over there? That is what the question is. So for example, let's suppose a developer developed something. Okay, that code is placed. Now that code will be built. You will start creating a package from that code. Okay, after the build, testing will be done automatically. Test cases will be called and testing will be done. Now, let's suppose any of the test cases fails. Okay, any of the test cases fail, automation testing is happening. Some Selenium or JUnit test cases are running. Let's suppose the testing fails. At that time, to the developer, a bug will be reported. Hey developer, there is a bug in the code. The test case is not passed, it has failed. What developer will do? Developer will create another version of the code. He will change the code. He will modify the code to fix the bug. He has to modify the code. So he's going to put another version of the code. Let's suppose this was V1. The code version is V2. Okay. Now from this version 2, you created a build earlier, build version V1. Now you will create a build version 2. And then use this build version 2 will again be tested. Let's suppose again something fails, a bug will be reported to developer. Developer will go and create a new version of the code after making the changes. In the V2, he will make changes, so version V3 will be prepared. From the V3, a build will be generated, which will be V3, and this V3 will again be tested. And this loop goes on and on and on and on until all the test cases pass. Until all the test cases are not passed, this loop goes on and on and on and on and on. And this is what is called as continuous testing. Any single bug fix, any feature update, a single line of code is also updated, then also it will be tested. Using some automation only it is tested, like Selenium JUnit, some automation tool will be used. But the testing is happening continuously. Whenever the bug is reported, some code will be changed. That code will be, from that code, a new package will be generated and that package will be tested. So this is what the continuous testing is all about. Automation means automating the task. You're writing some code to automate the task. Okay, so that is what testing is all about. And that is what the difference between automation and continuous testing is. This is the loop: planning, coding, building, testing. Basically, this is your CI loop and this is your CD loop. So testing comes in the CI loop, in the integration loop, where you build and test. You write the code, you build it, and then you test it. Once testing is passed, then you will go and release it, deploy it, operate it, and monitor it. This is your continuous deployment loop. DevOps is all about CI/CD, creating these CI/CD pipelines. You have to create this CI pipeline and the CD pipeline. Okay, starting from writing the code to the deployment of the final application. This is DevOps. This includes many things. Writing code, so maintaining code. Writing code is not part of DevOps. Code will be written by developer. But once the code is written, you have to maintain it. You have to maintain different versions of the code. Okay, you have to build it. You have to test it. Then you have to go and deploy it. After that, you have to operate it. And then you have to monitor it. These are the stages of your software development life cycles, which are handled by DevOps. DevOps is basically a methodology that automates all these tasks, all these stages. Okay. So now, what are different tools used for testing? Okay, tools. We'll talk about these tools. Like we have Selenium and TestNG. Maven is also a tool. Maven is basically a build tool. So we'll talk about these tools in a short while, but let's first talk about what are different types of testings that we perform. What are different types of testing? So we have heard many of the names: functional, unit testing, load testing, stress testing, integration testing, regression testing. What are these? So if I talk about them, functional testing means, by the name it is clear, functionally application is working or not. Like I gave an input and I get the desired output or not. That is what functional testing is. Okay. To check whether the required functionality that is mentioned in the requirement of the customer gave you some requirement. So in functional testing, we see that whatever was the requirement is actually working or not, is functionally working or not. That is what functional testing is all about. Second is your unit testing. Unit testing means, let's suppose in an application, you have different components. You have a front end, you have a back end, you have a middleware, you have a caching, you have a queuing server. Like one application has many components. So testing each and every component independently is called as unit testing. Okay, unit testing means testing smaller components of your application, small components. Okay, front end, back end, middleware, then you have any caching or any other layers, any other components that you have. Testing each of them individually and checking whether they are working together or not. They are working independently or not. Their functionality wise, they're working or not. That is what we check in unit testing. Okay. And integration testing, if I talk about this integration testing is all about when you combine all these units together. First of all, we test each and every individual unit. After that, we combine all these units together. Okay. After combining all these units together, we see that whether our final application is working or not. That comes under integration testing. So integration testing is all about integrating the components combined together and to see if all the components when combined together are giving the desired output or not. That is what is your integration testing. Okay. Then after this, we have load testing and stress testing, almost similar with a small difference. Load testing means you give enormous amount of load on the application. Okay, let's suppose you are creating an application that is going to back up something. You're creating a backup application. Now, how much data that application can back up? So you will start with 10 GB. Okay, that's fine. You will go more, 20 GB, 30 GB, 300 GB, 400 GB, 500 GB, 1 terabyte, 2 terabytes. So you will increase the load capacity to check how much load can the application can handle. Okay, so load testing is basically process of testing the performance of your application during heavy load. Like at 10 TB, when you're trying to back up 10 TB, the application is working very fine, very smooth. 100 GB, also good. But when you're trying to back up 300 GB or 1 terabyte, the performance, the backup is taking much amount of time. The performance is not good. So definitely you have to work on that part. The developer has to work on that part. That the application is failing the load testing, it's not good. The performance for when you're backing up big amount of volume, big amount of data, the performance is not good. So that will be tested under load testing. And stress testing, again, stress testing is a type of a testing to get a break-even point. Like at what point, what load you give to the application and your application will fail. That is called as stress testing. Simple thing to test the maximum load that your application can bear. That comes up under the stress testing. Almost similar, okay, with a small tweak. Okay. And then finally, you have the regression. Now, what the regression is all about? Regression is like, for example, as I discussed that, you make a small one-line change in the code. One-line change. So there, even if you're making that one line of change, you have to run all the test cases right from this beginning till the end. Because that one line change can cause other functionalities. It can hamper other features, other functionalities. Okay, so this is what a standard practice is. Like whenever a developer makes any code changes, complete test cycles have to be executed. Okay, it is not like that you have made a one line of change, you will test that only. No, it can happen that that one line of change can even a one word of change can break other functionalities, can break other components. Okay, so that to test all the features, regression means continuously testing. Even a small component is modified, you will be completely testing the end-to-end entire application. So such kind of testing is called as a regression testing. Okay, so these are different types of testing that are performed in the real world for our applications. Okay, now coming on to the tools, like what tools we use over here. Okay, so let's see the tools. Role of the continuous. So we talked about the tools here, Maven, Selenium, TestNG, Jenkins. Let's talk about these tools a bit in detail. Okay, so Maven, first of all, what a Maven is. Maven is basically a tool that can help you in automating the task, that can help you in building anything. Okay, that decides on the dependencies. For example, I'm writing some Selenium test cases, and that Selenium has some requirement. Okay, so Maven is a tool that will help you in managing the builds, managing the dependencies of the test cases. Like for example, I want to execute Selenium and Selenium requires a Java class. There's a special Java class that is required by Selenium. So who will fulfill that? That is required. That will be done by Maven. Maven is the tool. Maven is the build tool that not only builds the application, but it also goes and resolves the dependencies for testing. So that is done by Maven. Maven is given by Apache. Mainly, Maven is used with Java projects. For Python, we have something different. So we have many tools like Ant, Gradle, Maven. Maven is one of the build tool. Okay, so we have many build tools. Here, we'll talk about Maven because Maven is one of the most popular build tool that is used for mainly for Java projects. Any Java projects means application, a project that is built in Java. Okay, so that is what Maven is. If I talk about Selenium, what Selenium is, Selenium and TestNG and Selenium. So Selenium is a tool that is going to automate, that helps you in automating the test cases. Selenium is mainly used for testing web applications, web pages, any web application that you're developing. Okay, for to test that web page, web application, we will be using Selenium. Okay, and it can easily integrate with tools like Maven, TestNG, Jenkins, easily integrate. So Selenium is basically the tool in which you will be writing the code. You will be writing the code and that code is basically going to test your application. So Selenium will allow you writing that code. Okay, Selenium is the test tool. Maven is the build tool that resolves dependencies, that builds your application. Like for example, I want to build my application that requires some Java class. So that Java class will be pulled by Maven. Okay, Selenium will go and perform testing and then TestNG. So basically Selenium has few drawbacks. Like Selenium can automate your testing. Okay, that's fine. But Selenium is very bad when it comes to writing test cases. Like you want to write test case. Selenium will not be able to do it. You want to generate any report, Selenium will not be able to do it. Okay, so Selenium is really bad in doing such stuff. So to maintain those stuff, what we use is we used TestNG. TestNG is another tool that is mainly used for your managing test cases, writing test cases, and for creating test reports. Like, okay, Selenium, all the test cases that were run through Selenium are passed. Who will give the report? TestNG will give the report. Okay, so TestNG is basically a reporting tool and mainly used for performing, managing your test cases, which Selenium won't be doing it. Okay, and last but not the least, we have Jenkins. So all these test cases, normally nowadays, testing team writes it. DevOps engineer can also write these test cases, or developer can also write the test cases. Nowadays, there's a trend that, okay, that what happens here is, whenever a developer develops the application, along with that only, developer writes the test cases as well. Okay, instead of DevOps guy writing the test cases or the testing team writing the test cases, the developer only says, okay, we have to test all these things. They write their test cases. Now they can use Selenium, they can use JUnit, anything. Those are tools for executing test cases, for writing it up, for Selenium test cases or JUnit test cases. But yes, they do it up. Okay, and we just have to integrate those. We just have to call those test cases. Okay, we just have to call those test cases and execute those. That's it. And how we do that? We do that using a tool, is Jenkins. So Jenkins, there are many tools available in the market similar to Jenkins. Like you have Bamboo, TeamCity, Hudson. There are many tools which are competitors of Jenkins. But yes, Jenkins is one of the tools that is very widely used for integrating the things. It's an integration tool. Integration tool means, let's suppose you have the code. Okay. Now using that code, you will first build the code. Building the code means what you have to do is you have to create a package. You have to build it, because raw code cannot be tested. Nobody can test raw code. It's raw Java code. It's raw Python code. We cannot test it. You have to build it. After building, then you will run the test cases. Now, any testing, unit testing, JUnit testing, functional testing, load testing, stress testing, regression, whatever you want to execute, it's up to your wish. You have to test it. And then if all test cases are passed, you have to go and deploy it. That's it. Simple thing. So how you can integrate all these stages together, like starting from pulling the code, building the code, testing the code, after testing, deploying the product. Okay, because you have the code, you build the product, you tested the product, and then you have to deploy the product, and then you have to monitor it up as well. So how this can be done, how all these stages can be integrated. So for doing that, we use a tool called as Jenkins. Jenkins is an integration tool. A tool mainly used for automating the things, for integrating multiple stages. Okay, it can schedule your builds, deploy the code to production or staging server, any environment. You want to deploy, you want to build, you want to test, it will do it. And this is one of the tools that is very widely used. Okay, reason of its popularity is open source. It's the first tool, integration tool in the market. Along with that, the simplicity, the ease. I will show you Jenkins in short while. Okay, the simplicity or the ease that it provides for managing the things is very useful. It's very easy. Okay, so that's why people prefer Jenkins a lot. Okay, so let's see how this Jenkins will help me in achieving test cases, in managing test cases. Let's see over here. Okay, let's go and check it out. Okay, so what I've did here is to just show you a small demo over here. We'll see a small hands-on first. Okay, so to show you a small demo, I am on my GCP. You can see that this is my GCP over here. Okay, so to show you the demo, what I've did is I've created a machine. You can see this machine is there, instance number 1 that is running. Okay, and onto this particular instance, Okay, the IP address of this instance of this machine is this. You can see the IP address. It also has a public IP. And on this machine, I have installed Jenkins. I've already installed Jenkins. You can see that over here. This is the machine. Okay, you can check the IP. Okay, the IP for the machine is 10.128.0.3. And that is what you can verify from here. Okay, this is the internal IP. This is the external IP. Okay, so now what I can do here is just see systemctl status Jenkins. It's installed. To install Jenkins, you can simply go on Google and just type here on Google, just go here and type install Jenkins. I'm using CentOS. If you're using Ubuntu, you can use Ubuntu. So you can just go here, how to install Jenkins. And you can follow these steps. Like I'm using Red Hat CentOS. So you can follow these steps over there to install Jenkins on a server. Okay. Once Jenkins is installed, we can see that it's running over here. Yeah. Now what next I have to do is I have to just access this Jenkins UI. So let's go and access the Jenkins UI. I go here. Okay, I can reopen this if you want. Just a minute. Yeah, I can reopen this. So what is the IP of my machine? Let's see the IP address of my machine. This is the IP internal. External is this. Copy. Okay. And let me open this here. Followed by Jenkins runs on port number 8080. I hit enter. It says welcome to Jenkins. Guys, this is a public URL. You can also open this. I can put the URL on the chat box. Right now, I'm not sharing the ID and the password with you, but you can open this web page. Okay, let me put my admin password, admin and the password. Okay, so you can see I'm logged in. Okay, I'm logged in onto this. This server is created just before I started. Okay, like you can see the uptime. It will be around 30, 40 or maybe 1 hour, not more than that. Yeah, 1 hour and 14 minutes. This is the uptime. So before the start of the webinar, I created this machine. And at the end of the webinar, I will go and delete this machine. Okay. So Jenkins is running. I'm able to log in. Okay. Now, what I have to create a pipeline. What I need to do is I need to perform the code checkout. I need to perform code building. Then I need to test it. And then I need to package it. All those things I have to do. So for doing that, I have a sample Java code with me over there. You can see that Java code is here. You can see that 𝐂𝐲𝐿07 DevOps class codes. Okay. This is a Java code, guys. This is a Java code for building an address book. Like I'm going to build a page like this. Okay. So I will show you the artifact will be built. Okay. But deployment part will not go into, CD part will not go into. We'll mainly focusing on the testing part. So only CI part will focus, not the CD part. So if you want to see CD, then I have to install Docker, or maybe I have to install a Kubernetes server. And then on that, I have to deploy this as a container. I have to create a container, or maybe I can use a virtual machine as well. On that virtual machine, I can install Tomcat, and on that Tomcat, I can go and deploy it. But I will not do that as of now, because our main agenda is testing, not to understand deployment, CI/CD. So we are not into that. So let's see how we do it. Okay. So you can see that right now, this is the code SRC. If you see the folder SRC over there, this is the application code over there. So it's written over there. Can you see these files, Java files? See this Java file. You can see the Java code. Okay, this is the Java code for my application. Okay, you go into the main, or you go into this SRC. You go into the main, and you go into the PMD or whatever. Can you see these all XML files? Okay. All Java files over here. Okay, you can see this tutorial address book, and you will be able to see all the UI Java. You want to see the UI file. Okay, so this is a Java file again. You can see this UI file. Okay, all this is a code a developer has written it. As a DevOps engineer, it's not my job to write it. Okay, we don't have any separate DevOps engineer is not going to write it. Only a developer will go and write it. Okay, so if you don't understand the code, that's fine. No need to worry. We are going to see how we execute this. Okay, how we build it. Okay, this is the raw code. And along with this raw code, test cases are also written. You can see that. Can you see these are test cases? If you go into this Java 𝐂𝐝𝐻 Edureka demo utilities, These all things like exception thrower.java. See, you're testing something. Int I equal to 10 log info plus I. Throw new input output exception. Then you're automating, you're writing test cases. See, these are the test cases that are written. So when you will go and deploy, you will be using MVN to test Maven, Maven for building, Maven for packaging. All these things you're going to use. Okay. So let's see how we do it. Yeah. So this is the code. In the code, this is my source folder. In the SRC, this is the application code. And this is the test cases that I need to execute. Okay. So how to automate this? Simple. Let's go on to Jenkins. Let's create a job. Let's create a Jenkins job, a project, a build job. I click on new item. Okay. You can name anything like my Java project. Okay. I can name it anything. I'm going to use a pipeline. I need to show you everything in the pipeline. Code checkout, code building, code testing, then code packaging. Okay. So I will be, if I show you the pipeline over here, this is a pipeline look likes over here. You can see that. Okay. Just a minute. Let me open it up. So this is the pipeline that you can see. So what I'm doing here in this is, let me put it on a notepad. Okay. So this is the pipeline. I can put this pipeline for you guys if you want on the chat. I'm not sure if it will come on the chat or not, or maybe I will upload the file. Just a minute. Yeah, I think it's coming up. So you can copy it from there as well. You can copy that pipeline as well. Okay. So that is what my Jenkins is going to deploy. My Jenkins is going to run. So see what I'm doing over there. See, first stage is a checkout stage where I'm just doing a git checkout. I'm copying my code. Okay. Now, after I do a copy of the code, I do a git checkout. After that, I do a compiling. So for compiling, what tool in Jenkins I'm using? I'm using Maven, MVN as a build tool. MVN compile. Compile my code, because once compiling is done, then only you can test it. Raw code cannot be tested. A compiled code are only tested. Nobody can test raw code. Okay. Once compiling is done, compiling means once you get the compiled code, okay, which is in the form of which your computer system can understand, that code you will go and test. So for testing, I'm running a command, Maven test, MVN test. That's it. So MVN is basically Maven. Maven is installed on Jenkins. If you want to check, I can show you that as well. Like I go onto my browser and I show you here which Maven. See, Maven, or maybe I can do here MVN -- version. I think it is not copied there. So you can see, yeah, it's there. Maven. Can you see the version of Maven that I'm using? Sorry, it's in OPT Maven. It's not in this. So MVN -- version. See, Maven is there on my system. Okay. And I'm going to use this Maven as a build tool for deploying, for building my application, for testing my application. So as a next step, I'm just going to do an MVN compile. After the MVN compile, I'm doing an MVN test. Now, once all the test cases are passed, then it will go and create a package. The file that is ready to be deployed. This is, guys, my CI. This is what my CI pipeline is. Okay, CD comes after this. Now, where you need to deploy on a VM, on a container. So I will extend this pipeline. I will extend the more stages, but we are not going to do the CD part as of now. We'll just keep it ourselves restricted to CI. For CD, basically, we cover all these things in our training program, in our DevOps training program, CI, CD, Terraform, Ansible, all those things we cover. Okay, but yes, let's see how we do it up. So let's create this pipeline. Okay, so let's open this. Right now, what I'm going to do is copy this over here. From here to here, I copy this completely. Control C. And I go back to my Jenkins. And I create my Java project, which is a pipeline project. I click OK. Once you click OK, a project is created. See, it takes me to the next page. Now in this, I don't need to do anything over here. I just need to put my script. It's a groovy script. So I just have to put it up here. That's it. Okay. I have to give my pipeline. Okay. And I'm just giving all the stages: git checkout, MVN compile, okay, MVN testing, and then MVN packaging. All these things I'm giving. Okay. Finally, apply this and save this. Okay. So right now, my job is ready. You can see my job on the backend. CD, if I do var lib Jenkins, this is the data path for Jenkins, PWD, I'm in var lib Jenkins. CD to workspaces, okay, ls minus al. Okay, right now, nothing is created inside this workspace. When I will go and execute, right now, see, nothing is there, ls minus al. And what's my PWD? So right now, nothing is there. Let's go and execute a job. Let's go and execute my build job. Let's do that. Okay, so how to do that is just you have to run this. You have to execute this. So click on build now. So once you're building it, you will see different stages coming up. The first job started, git checkout is happening over there. Now it is doing a compile. Okay, compiling. Now it is testing the thing. Okay, test cases are getting run up here. Okay, now testing is happening. After test cases, it will go and package it up. It will building it up. It's building, it's creating the package, the final package. And it's successful. See, this is green. This is green. Okay, so this is what DevOps is all about. Automating the thing. It's taking the code, compiling the code, testing the code, and then building. On the back end, you see here, earlier this was empty. Okay, now you see ls minus al. Can you see this my Java project created? Because you ran the first job. You created the job, that's why it created the folder here. cd to my Java project, ls minus al. Can you see the complete source code over there? See, all these files are present on GitHub as well. See this GitHub. See, src Docker file I'm not using. I'm not using Docker over there. Docker is mainly used for deploying it. Okay. README, address book, build.properties, build.xml, pom.xml. So 1, 2, 3, 4, 5, 6, 7, 8. 8 files are present. See these 8 files. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think one more is created right now. Yeah, this one, this address book.yaml. Let me see that. Is it was there? 1, 2, 3, 4, 5, 6. Oh, 9 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9 files. 9 direct there, and you can see exactly same over here. So my code is checked in. It has been checked out over there. Apart from that, can you see a target folder as well? From where does this target folder comes up? Whenever you compile Java, okay, Java code, you compile Java code, it created the target folder. cd to target. Maven created this because Maven did the compilation. ls minus al. Can you see this final output? Can you see these classes? You go to cd classes, ls minus al. Can you see this cd to com? Basically, let's go to com, ls minus al. No, I think it's cd to Edureka demo. Where's the class file? No, I think it's not here. I think, let me just go back, ls minus al, cd to address book, ls minus al, where I think it should be, the classes file should be inside this only. Yeah, let's see that classes file, cd to classes, sorry, cd to classes, com Edureka demo, and let's go into the helper. Yeah, can you see these class files actually? See this, ls minus al. Can you see these class files? What these class files are? So whenever you have the code, you have the Java code with you. Okay, whenever you compile the Java code, after compilation, you will be getting a class file in the backend for that code. See the class file. This file was not present in my code. You want to see the code, actual code? Let me show you that on the GitHub. Okay, let's go back on the GitHub. I go on the src, I go on the main. Okay, I go here. I go into the helper. See, it was a Java file, .java. It was a .java file. Source code was .java. When you compiled, in the end, the compiled output is .class. So now compilation is done. After the compilation, you will do all the test cases. Once the test case is passed, you are going to package it. And this is what your final package is, the one in the red, addressbook.wall. Now you can deploy this on Tomcat. You can create a server, you can create a CD pipeline. On that, you can deploy a server. On that server, you install Tomcat. On Tomcat, you go and copy this and execute this. That's it. That will be a part of CD. My job is not to go with CD as of now. I'm going to show you CI, and this is CI. Can you see this file, this WAR file? WAR stands for Web Archive. Web Archive. That is what it is. Okay, Web Archive. That is what your WAR file is. So this is your final output. This is the final deployable artifact. You want to check the logs? Let's see the logs as well. Okay. I will give you the logs. Okay. Okay. Let's see the logs over there. Let's go to my Jenkins and click on this number 1 job. Okay. You want to see the console output? See the console output. Okay. So on the console output, it first running the job in val-lib Jenkins workspace my Java project. Okay, that's fine. Okay, now you see it did a git config, git all these things it did. Now after that, Maven compile, it's compiling the things. So when it started compiling, it called the Maven. Okay, to compile it, it created inside the target, it created the classes folder. See this folder. Okay, inside this folder, it created addressbook UI. .java will be compiled to Java, will be compiled to .class files. It will start creating all the class files for the tools. Okay, once the build was success, then it tested all the class files. It's doing the testing right now. See this testing, test cases, running the test loggers and all these things. Okay, so after testing, once the build is success, then it go to the packaging. And in the end, you will get your final package. See, if you scroll down over here, build success, building WAR file in this. See this. val-lib Jenkins workspace, my Java project, target addressbook.war. See this. Can you see the file on the back end? Yes. See, what's my PWD? Sorry, let me go back over there. CD val-lib Jenkins workspaces, my Java project, target, my Java project, and then target ls-al. See my PWD. Inside this, you have this file, val-lib Jenkins workspace, my Java project, target, and that is what my log says. Val-lib Jenkins workspace, my Java project, target. Inside that, you have the final file. This file you have to go and deploy now using a CD pipeline. So CI pipeline we have seen, but this is how we test. This is how we integrate this. Okay. Thank you and have a wonderful day ahead. Bye-bye.